In this demo, we will first show how to set up the 15 MHz V260-SM Sonopen delay line transducer to make measurements on a 0.362-inch or 9.2 mm diameter aluminum tubing sample with a wall thickness of 0.013 inches or about 1/3 of a millimeter. Since we are going to be measuring small diameter tubing, we will also use the SLH-V260-SM spring-loaded V-notch holder. For this demo, we will use an Olympus 38DL Plus thickness gauge. The exact key presses would be different if you were using a different model Olympus thickness gauge, but the overall process would be the same. Sonopens do not have permanent delay lines. The Sonopens require couplant under the removable delay line, since without it the sound will not be transmitted. Therefore, we recommend checking under the delay line tip to make sure there is couplant. To do this, the user would unscrew the delay tip. If it is dry under the delay line, the user should add a few drops of glycerin and then screw the delay tip back on. We can now set up the spring-loaded holder. The first step would be to loosen the set screw on the spring-loaded holder using a flathead screwdriver. We can then insert the microdot end of the V260 into the V-notch side of the spring-loaded holder until it cannot be inserted any further. Then we will use the flathead screwdriver to tighten the set screw so it holds the transducer securely. We can then connect the microdot end of the transducer cable to the V260 and then plug the LEMO end of the transducer cable into the TR1 port on the top of the instrument. Then turn the instrument on. The user may need to make some minor adjustments to the holder as needed depending on the application. It is also important to note the V-notch crown on the holder can be reversed if needed. Now, once the instrument is on, press the XDCR recall key. Since we are using a 15 MHz transducer, we will press the down arrow to default single element and then press Enter. Here you will see the list of default single element transducer setups. Since we are measuring thin metal, we will want to make a Mode 3 measurement. Therefore, we will press the down arrow to highlight DEFM 3-15.0-V260. At this point, you can press the red Measure key to recall the setup, or press the Enter key to see the parameters within the setup. If you press Enter, press the red Measure key next in order to recall the setup and return to the measurement screen. The default setup we recalled has a default sound velocity for stainless steel, so we need to change it to something closer to aluminum. To do this, press and release the second F key first, and then press the CAL-VEL key. The stainless steel velocity will be displayed. Use the arrow keys to change this value to the approximate sound velocity for aluminum, which is 0.2490 inches per microsecond, or if you are using metric units, it will be 6.325 millimeters per microsecond. Then press the red Measure key. We can now apply couplant to the part and couple the transducer onto the sample and pull down on the spring-loaded holder, so the part is seated in the V-notch. We begin to get a reading which appears to be correct. However, there appears to be some potential interference from the trailing edge of the delay line echo. Also, since aluminum is a good transmitter of sound, there are cleaner multiples further out in time, which do not have the potential to be interfered with by the trailing edge of the delay line echo. Therefore, we will adjust the IF blank until the gauge measures the cleaner backwall echoes that are further out in time. To do this, press the Wave Adjust key, then press the up arrow to IF blank. Then we will press the right arrow until the gauge is measuring clean multiples. We are now making a Mode 3 measurement of the aluminum thickness. To ensure these measurements are easily captured, we will increase the initial gain slightly. To do this, press the up arrow to INIT gain. Then we will press the right arrow to increase the initial gain. At this point, the user should calibrate using samples of known thickness. For best accuracy, they would calibrate using 2 samples of the same material with known thickness representing their minimum and maximum thickness. Once this is completed, we would recommend saving a custom setup. To do this, press the XDCR recall key. Now, with the active setup highlighted, press the Save Send key. This will bring you to the Save Setup screen. Here, you will notice that Save As is highlighted and a virtual keypad appears on screen. You can now use the keypad on screen to enter in a name for the custom transducer setup. We will name this setup AL-V260. Use the arrow keys to highlight a character, then press the Enter key to input the character into the Save As line. As you input characters, the existing setup name will start to be overwritten. Once you have finished entering the name of the custom transducer setup, use the arrow keys to highlight the right arrow, then keep pressing the Enter key until the last character on the Save As line is highlighted. Then use the arrow keys to highlight the word Delete, and then keep pressing the Enter key to delete any unwanted characters. Next, use the arrow keys to highlight Done in the center of the keypad, and then press the Enter key on the instrument. Now, the Save To line will be highlighted, and you can choose where to save the custom transducer setup. Use the arrow keys to highlight an available SE user number. Then press the Enter key so Save is highlighted. Then press the Enter key again. The active screen showing all the setup parameters will now be displayed. From here, you can press the red Measure key to return to the measurement screen. We will now show how to set up the V260-SM Sonopen delay line transducer to make measurements on a 0.320-inch or 8.13 mm diameter plastic tubing sample with a wall thickness of 0.029 inches or about 3/4 of a millimeter. Since this is also a tubing sample, we will once again use the spring-loaded V-notch holder. The first step would be to press the XDCR recall key. Since we are using a 15 MHz transducer, we will press the down arrow to default single element and then press Enter. Here, you will see the list of default single element transducer setups. Since plastic does not produce strong multiples, we will be unable to make a Mode 3 measurement and will therefore want to make a Mode 2 measurement. So we will press the down arrow to highlight DEFP2-15.0-V260. At this point, you can press the red Measure key to recall the setup, or press the Enter key to see the parameters within the setup. If you press Enter, press the red Measure key next in order to recall the setup and return to the measurement screen. The default setup we recalled has a default sound velocity for plastic, so we do not need to change it at this time. Since we are measuring a thinner sample, we will change the range by continuing to press the blue Range key until the bottom right side of the waveform shows 0.57, or if you are using metric units, it would display 14.6. We can now apply couplant to the part and couple the transducer onto the sample and pull down on the spring-loaded holder so the part is seated in the V-notch. We do not get a reading, and we observe a delay line echo which is lower in amplitude than the backwall echo on screen. Olympus thickness gauges use automatic gain control for the amplitude of the backwall echo. Therefore, the backwall will appear as 80% screen height. The delay line echo, by comparison, is much lower in amplitude because of the impedance matching between the plastic delay line and the plastic surface of the tubing sample. The backwall echo, which represents a plastic-to-air interface, has a larger impedance mismatch, and therefore a larger echo amplitude. The delay line echo appears negative, so we will need to change the echo 1 detection. To do this, we will press the Wave ADJ key, then we will press the up arrow to echo 1 detect, and then use the left arrow to change it to negative slope. To help increase the voltage response from the delay line echo, we will increase the voltage used to drive the transducer. To do this, press the up arrow until you get to the pulsar power setting. Then press the right arrow twice to increase it to 200 volts. The delay line echo is still not large enough to be detected, so we need to increase the initial gain. To do this, we will press the down arrow to INIT gain. Then we will use the right arrow to increase the initial gain until the gauge is making the Mode 2 measurement. You will notice that due to the automatic gain control, the delay echo is still low in amplitude. This is fine as long as the gauge is making proper detection, which it is. At this point, the user should calibrate using samples of known thickness. For best accuracy, they would calibrate using 2 samples of the same material with known thicknesses, representing their minimum and maximum thickness. Once this is completed, we would recommend saving a custom setup. For this demo, we showed how to make the plastic measurement using the standard Sonopen delay tip. As discussed in previous slides, using the higher temperature DLP-301 delay tip may be a better choice when measuring some plastics, since it can help create a stronger delay line echo by offering a greater acoustic impedance mismatch. As you can see from the images shown, when using the same transducer setups, the screenshot that utilizes the higher temperature DLP-301 delay tip creates a stronger delay line echo, and the gauge is already making detection. Therefore, if you are having trouble detecting the delay line echo when using the standard delay line tip, you should try using the higher temperature DLP-301 delay tip.